In this video, we are going to study about the probability of the event. Here, the number of elements in the set of event, here n is shown, and the number of elements of the sample space is shown with the ns, and the probability of the event is becoming n number of elements in the event set over number of elements in the sample space. We are defining like that. Okay, now with simple examples we are going to try to understand this formula. Probability, what a coin tossed, what is the probability of obtaining tail? You know, when we toss the coin, there are two possible cases, head and tail. So the sample space, it's going to be head or tail. So this is the number of elements in the sample space, which is equal to 2, and they are asking the event obtaining tail. So it means that the number of elements in the sample space, event is equal to 1. So probability of the event is going to be equal to 1 over number of elements in the sample event over number of elements in the sample space, which is equal to 1 over 2 is going to be. Okay, this is the probability of the event. Okay, here when we roll the dice, what is the probability? The number is odd. So you know the dice, and this is the open form of it. So there are 6 sides, 6 faces, and as a sample space we have, it means that 6 different faces. These are the faces. Numbers on the faces actually. Okay, there are 6 numbers, and it says that what is the probability the number rolled is odd. Odd numbers are here 1, 3 and 5, so the event is equal to 1, 3 and 5 it's going to be. So there are 3 elements here, totally there are 6 in the sample space, so probability of the event is going to be equal to 3 over 6 number of elements in the set event, and number of elements in the event set, and number of elements in the sample space. So it's going to be equal to 3 over 6, which is equal to 1 over 2 is going to be. Okay, if we continue, here the coin tossed 3 times. So if you remember the previous lesson, when we tossed it 3 times, we have written the sample space. Sample space, it's going to be with head, and head, then head and tail, head, tail, head. It's going to be this time head, tail, head, and head, tail. It's going to be tail. The same here, it's written with tail, head, tail, head, tail, head, and tail, and tail is going to be. So in the sample space there are 8 elements, and here it says getting only 1 head. Here 2 heads, 1 head. This is the case. 2 heads, this is 1. 2 heads, 1 here. Here there is no head. So getting only 1 head means there are 3 cases. The event is head, tail, or tail, head, tail, or tail, head case is going to be. Okay, how many different way we can do this one? 3 different way. Okay, then the answer is probability of the event is equal to 3 over 8. It's going to be number of elements of the event and number of elements in the sample space. Okay, let's continue. In integers, the integers 1 to 15 written on a separate card, so we are writing on a separate cards, but I'm going to write the sample space here, 6, 7, 8. Okay, then you're asked to pick a card randomly. What is the probability of you pick a prime number? So when we finish this set here, this is the sample space. It's going to be 10, 11, 12, 13, and 14 and 15. In this set, you know that one, there are 15 elements. Number of elements in the sample space is 15. What is the probability to pick a prime number? Prime number set, this is the event 1. So event 1, I'm going to say, picking a prime number. Which numbers are prime number? 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number, 9 is not prime number because it's divisible by 3. 10, 11, 10 is divisible by 2, 11 is a prime number, 12 is not prime number, 13 is a prime number also, 14 is not prime number, 15 is not prime number is going to be. So there are totally 6 prime numbers. So the probability of the event is going to be, probability of the event 1 is going to be 6 over 15, which is divided by 3, 2 over 5 is going to be. Okay, the second one, this is the A. Second one, probability pick a even number. Even number, we are going to pick even numbers. So 2, 4, 6, 8, 10, 12, 14 is going to be. So there are 7 even numbers in the set 1 to 15, and it means that probability of the event 2 is equal to 7 over 15 is going to be. We cannot simplify. Okay, for the C1 now, this is the third event it's going to be. The numbers divisible by 5 means here 1, 2, 3, 4 cannot be because 5 is only divisible by, and 10 and 15 they are divisible by 5. It's going to be, I said 3, sorry, and these are going to be 5, 10 and 15. So there are 3 numbers in this set. Elements of the set is 3. Probability of the event 3 is going to be 3 over 15. When you simplify by 3, 1 over 5 is going to be. Okay. A child is throwing darts at a board shown. In this question, they are asking a child is throwing the darts, and what is the probability the child's dart lands in a red circle? To hit the red circle we are looking for, and extra information, all the radii are given here, 3, 6 and 9 centimeters, which means for the red one if it is 3, for the yellow one it's going to be 6, and for the blue one the radius is going to be 9. So what is the probability of this one? Now we are going to find the probability of the event. It's going to be number of elements in the event and number of all in the sample space. But here we don't have elements here, so we are going to find the total area of because the probability and the area directly proportional it is here, and probability of the area or the area over total area, the ratio, it's going to give us the probability of the event. So what is the red part? It is going to be pi 3 square, which is equal to 9 pi, the area of red. Area of the red is going to be area of all, which is sample space, is going to be pi 9 square, which is equal to 81 pi. So 9 pi over 81 pi is going to be equal to pi and pi you will simplify, 9 and 81 you will simplify, and the probability is going to be 1 over 9. Okay. A card is drawn from a deck, 52 cards. What is the probability of the card? This is spade. You know, this is heart, this is diamond, and this is spade. And what is the probability that card is spade? If you know the cards, we are going to do like this. Here, firstly, we need to know there are 13, and 13 totally 52 cards, 13 spade, 13 diamond, and it goes like that. From each we have here, from each figure we have 13 different cards. From spades, 13 spades we have, from diamonds, 13 diamonds we have. So totally 4 different cards there are with respect to these figures, and totally there are 52 cards. So what is the probability that card is spade? Is the number of the spade is 13. So the probability of the event is going to be number of elements in the space is 13. Set is 13. Number of in the sample space is 52, which is equal to 1 over 4 is going to be, because 52 is 4 times 13 is going to be. Okay. A pair of dice rolled, and what is the probability of the sum is greater than 6. The sum is greater than 6. So if we make here some one table here, as you see the table here, as you see, and the sums are given here: 1 and 1, 2 and 2, 3 and 3, or 1 and 3 is 4, 4 and 3 is 7. All the probabilities are given here, sums are given here in this table. So the pair of dice rolled, what is the probability their sum is greater than 6? Here these are 6, maximum 6, these are minimum less than 6 or equal to 6, and these are greater than 6. So there are totally here the sums totally they are 36 sums in this set. Number of set is equal to 36, and you have to draw this figure also. And number of elements in the event set. Here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21. There are 21 elements in this set. So the probability of the event is going to be 21 over 36. When you divide by 3, this is going to be 12. When you divide by 3, this is going to be 7. So the answer is 7 over 12 is going to be. Okay. Here, a child randomly presses the switches, and what is the probability? Bulb lights. This is, serial connection, and in serial connection, all they should be closed, so the light bulbs. So, bulb lights, there are two possible cases: open and closed, open and closed, open and closed, like head and tail example. And we want all of them they are open. Let me write all the elements in the sample space: open, 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 closed, open, open, closed, open, closed, open, open, closed, closed. So closed, open, open, closed, closed, open, closed, 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 open, and closed, closed, closed. It's going to be, when they are open, it's not going to light. When they are closed, it's going to light. So there is only one case that closed. So which one is closed? Then here there are totally, in the sample space, there are totally 8 elements, and one of them is only our answer, which is closed, and closed case. So the answer is probability of the event is going to be equal to 1/8. In a game, player bets on a number from 2 to 16 and rolls 2 dice. If the sum of the dice is the number he guessed, he wins the game. Which number would you advise to player to bet on, and why? You know, when we write the table here, as you see there are the sums. The sums are 6 here, or the sums are 8 here, and here also the sum is 7. The sum is 7. As you understand, there are 5 6s, there are 6 7s, there are 5 8s, and these are decreasing. So which one we will offer? We will offer for the 7, because the probability is the probability of the 7 is going to be 6/36. The rest of them, they are less than the probability of 7. Probability of 6 is 5/36, or probability of 8 is again 5/36, and only the 7 has the most probability, which is 6/36. That's why we should offer him to say 7